Hi there. This is my solutions to the final exam for MEEN 10005 for the spring of 2017. You were given a file. It was zipped. I guess I should have pulled up the zipped one, but anyway, once you unzipped it, this is the file you would have received. Oh, look, there it is. From I think I did put it on Canvas. Or if you took it at the testing center, you would have this full file on the flash drive given to you from the testing center. So once you open up SolidWorks, and I'm using 2016, there are several ways to get these parts into the SolidWorks. The easiest is if you're running 2016, you can just grab the assembly here and drag it and drop it into SolidWorks, and it will open up that assembly for you. And so there it is. If you were using a version earlier than 2016, you would have to come in and open up this step file. And I'll show you how to do that. Go to the file open, navigate to where that folder is, file, and I've got all files here. Then open up the step file, double click, and it will process it and open it up. Either method is acceptable as long as you get the parts into SolidWorks. I like to have my lines edge showed. So you can see that this here, nothing is constrained. So anyway, so this was a step file. I'll delete that and work with the other file. This is the file that came in the SolidWorks format. As you can see here, this pin has been fixed in place. I noticed in the grading that some of the pins were not fixed in place. I'm assuming that those came in through the step file. I did not dock you for that. I did make a note that you probably should have fixed that pin. Just makes your assemblies easier. So first thing I'd do is move these out so that I can get into doing my concentric mates. And so I'm going to click two surfaces and it'll automatically pull up this window, and I'll do that. And I'm holding the control button to select the two different surfaces and hit the concentric. Control button, pick the two control button, do all those. We're going to make this one here. This is an inner bushing and this is an outer one. And okay, so now we have everything lined up concentrically to the pin. So next thing we would want to do is to start our coincident matings. So these two here are the same length, so we'll just grab those two edges and mate them. Okay, and I know if I was designing this part, let's see where they've got their planes at. I would, okay, that one's in the middle of the part, and this one here is also okay. See, that's one thing I like to do when I'm designing my parts, is if you build things symmetric about the plane and you want to mate those things together, you just grab the plane and you can mate them, and now that thing is symmetric about the axes. If close this off, is my measure tile up? Yeah, if we measure, and you'll see from here to here is normal distance of 0.164, and from there to there is 0.1604. So that has put those right smack dab in the center of the part, which is good. So let's. This is another method of mating too, is to open up the mate tile box. this doesn't require you to hold the control key to select your parts. You just select the two parts that you want to mate, and it'll default to the most accurate, or most probable mate that you want, and all those went in coincident. Okay, so now everything is mated in coincident. Okay, so and quite a few of you stopped at that point. I didn't mark you wrong if you didn't do this, but just a little bit nicer is if you link those so that as you move one, they both move. It wasn't specified in the instructions to do that, but it's just, I think it makes it a much better assembly if you do mate those together so that they move. Because in an actual system, with another link going down, those would move in tandem with each other. Okay, and we'll just so there is step one of the exam, and I do have the PDF open right here. So we've created the assembly fully defined. Okay, not completely full defined because these are still movable, but I'll bring that up in the extra credit portion. Where'd my PDF go? Oops, not that one. This one. So the pin was fixed. We've did the concentric and coincidence mates. So we've got part one done. Part two, use a generic SolidWorks drawing C to create a drawing, the one shown. Okay, so let's call up that drawing to see what it looks like. So this is what we need to create for part two. And we want to make sure that it's in a C size scale. So there are several ways to get this part into a drawing. Now we're going to go ahead and save this so that rebuild and save. The way I like to get my parts into a drawing is simply push this button right here, which is a link that will open up a drawing, and we're going to select the C. Okay, and it brings that part. Well, it should brought the part in. So now we're going to pull up all these views that are in this drawing. So we'll need a front view, a right view, and a top view, and then from that we'll get our section view. We'll create an exploded view and our isometric view. So we'll start with the front view. We'll grab that, bring it down here, and do our top view, our right side view, and the isometric view, and right mouse click to end that edit, and this is placed over here. Okay, so there's those views, and then we need to do our section view right here, section AA, boom, showing that. So we'll come up here to this file layout and click on the section view, and we'll come to this view here and let that snap to the center, and that's all we want. So we'll say OK, do auto hatching, exclude, and OK, and then bring this right over here, and there's our section view. So now we need to go create our exploded view because we don't have that. So I'm going to use this here to create the exploded view so that it'd be the same. So I'm just going to right mouse click on there and go to here to open up that assembly. We'll go to the exploded views, which is this button right here, and I'm going to leave the pin fixed and move everything else. So we're going to grab this guy here and move it down a ways, grab this guy and move it down a ways, and then let's see, we're going to take this one, we're going to move it out. Nope, not that way. That was the wrong. We want to go this way, and I'm going to move a little bit further because this one here needs to come right here, and then this one here needs to go out here, and this one here needs to go out there. Okay, so that is basically the same as what we have here in our drawing. The spacings may be a little bit different, but it's still a general idea. Okay, so we're going to save that, and if we come over here and collapse that, because we're going to need it collapsed for the last extra credit part. So now let's go back to our drawing. I'm hitting Control Tab to pull up the open documents, and just click on that one. And right here we're going to insert our exploded view. So if we come to the view palette, okay, it says it's out of date, so we're on the chain assembly. Refresh the page, that'll bring all that up. And right here is the exploded. Now there's a couple ways to do this. We can do the exploded view, okay, and we're going to need to scale that down just a little bit, and we'll just click on this guy here, custom scale, go 1 to 1's a little small, 1 to 2's even smaller. Otherwise stupid. Hey, don't call me stupid, that hurts my feelings. Okay. Now it does not necessarily have to be tied. See, right now it is tied to that view, and we don't necessarily need to do that. So we can right mouse click on it, go to alignment, and break alignment, and now we can move it to wherever we want. Okay. Getting a little crowded here. Okay. So the other way you can have done that is, let's just move this guy over here for now. If we go back to this guy, pull up the isometric view and bring it in here. Let's change our, click on that view, change to the 2 to 1 scaling, and then if we right mouse click on that and go to properties and select show in exploded view and hit OK, it'll explode it out. So either way will work. Okay, I'm going to delete that guy. Yes, and bring this back here. Okay, so there's our drawing. That was problem number 2 in the instructions. Oh, that was problem number 2, 3, and 4, and 5, and 6. Wow, look at that. I just did the 6 problems. We created each view, which I did, the left, right, front. 4 was to create the section view. We did that there. 5 was the isometric view, which is this one over here. 6 is the exploded view. And number 7 is the extra credit. Okay, the extra credit is to create the table, the balloons, and fix chain to 120 degrees. Okay, so the table is basically a bill of materials. We'll do that last. Let's go in and now we need to establish the 120 degrees that is required for problem number 7 for the extra credit. There's several ways to do these. One thing that's really difficult in SolidWorks is putting dimensions where they're not normally put. So I like to cheat a little bit. Basically what I've done here is again I tabbed to go back to my drawing. If I right mouse click on that part and go up here to open part, it'll open up the part for me. I'm going to, where's all my views at? Standard views, there we go. I'm going to look at the right side of this thing, and I'm going to put a sketch on here. Again, this I wouldn't expect you to do this way. This is just something I've been doing over the last 100 years that I've been working with SolidWorks. I'm going to put a sketch there, and go back to the isometric view and save it, and Control Tab, go back to my drawing, and pull off this part, doing the same thing. Right mouse click, go to open part. Don't want to do that. Again, I'm going to go to the right side view and do a sketch. From there, to there. And then if we go back into our sketch, and if we click on this part, and come down here and right mouse click on that and show that sketch, there's that line. And this part here, and go show that sketch. And now if we do a dimension from that to that, we'll see that it's really, really small. Let's go to our properties for this page, document, dimensions, arrows, offsets, font, and let's go up to a 20 font. Okay, so there we can see that we're at 138 degrees, and we want to make that 120. So how do we do that? Okay, this is how I would do it. Again, there are several ways to do this. Okay, I'm doing a control tab, going over here to my assembly. We're done with these drawings, so I'm going to right mouse click on them and hide them, just because they're kind of annoying. And hide. Okay, so we have these guys here that are tied to each other, and we want to make them 120 degrees. So if we grab this guy here and close all these other ones, go this guy here, open, and we see that that plane there is running down the direction that we want to tie our 120 degrees to, and this guy here would be the same thing, that one. So if we take that and that one, so I got the two top planes, and do a mate. Okay, it's coincidence, but we want to do 120 degrees. Okay, so now they're always 120 degrees from each other. Now we want to get that so that that is symmetric. Why are you not showing my axes? I'd show temporary. So now to get these so that they're symmetric about the what was that, the right plane. If we select the right plane, go to our mates and come down here to advanced mates, and we want to do a symmetric, and we want this axis and that axis, and it is now symmetric about the plane. And we can go back up here to our view, hide show, and turn off our temporary axes, and turn off the axes. And now that is set to where it's 120 degrees symmetric about the right plane. Again, if you set it at 120 degrees, it didn't say anything about being symmetric about the plane. That's just some of my OCD kicking in. Okay, so we got 120 degree set, so now we need to add the table and the balloons. We select one of our, I'm going to select this view right here, and we come up to tables, bill of materials, and top level only, and we'll hit that OK and come and lock that in place right there. So now if you scroll in here, if there was a description for each part, it would show up in this bill of materials. So we have pin, sleeves, and inners and outers. Okay, so now to make it identical to the drawing, okay, I'm in the other corner, but that's okay. Now we'll hit our balloons, and we have a balloon on this one, 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 and just so on and so forth. So there's a lot of balloons. Personally, I just do it in one view. But this is good because especially in this view, because you're seeing number 2 here that you don't see in a regular view. And then I'm gonna come off to the bottom because the top has run-ins to that other. Oops! Oh, I missed. Oh, okay, that's okay. We'll just come back and delete it. Lots of balloons. Good thing we don't have to blow all these up. Oh, oh, he made us stupid. And that one's our double ballooned. And there you have it. I guess if you want to label your views, you'd click on the text box over here, put it down here, and exploded view. Control all, and let's make that a little bit bigger. And there you have it. That is how you should have had to do that exam. Let me know if you have any questions. Oh, save it. Save it. Okay, thanks.